All right, let's dive in. Today, we're tackling something pretty cool: magnetism. And not just the basic stuff, but how we can actually see it, visualize it, even play around with magnetic fields using, get this, online tools. Yeah, we're talking those open educational resources. Have you heard about these things?
Oh, yeah, they're like this gold mine. I mean, free learning stuff for anyone, anywhere, as long as you got the internet, right?
Spot on. So for this deep dive, we found this awesome website. It's from Open Educational Resources Open Source Physics at Singapore. Mouthful, I know. But they've got this simulation, and it really lets you get hands-on with magnetism.
It's like, those classic experiments with the bar magnet, the compass? Well, this is the same idea, but all
And
virtually.
you can actually move things around, right? Like the compass, and you see
Yeah,
the needle change right there on your screen in real time. They even have a screenshot on the site to give you a sneak peek. But it's got to be way more than just looking at a picture, right?
oh, absolutely. What I think is really neat is they have a whole section just for exercises,
Yeah.
like activities built right in to get you thinking about the concepts.
I saw one called Finding the Hidden Magnet. Sounds like a fun challenge. Imagine trying to figure out where the magnet is just by how the compass needle moves. Could you do it?
Trickier than you might think, honestly. It forces you to think about, okay, how do magnetic fields actually work? How does the compass react to these invisible forces? And get this, there are buttons to hide the field, then show it again. So you can really test yourself, if you're understanding it right. Super clever.
So, we've talked about seeing the field, even playing hide and seek with a magnet. But how accurate is all this? How realistic is this simulation, really?
Well, you can remember, it's still a model, right?
Yeah.
It's simplifying things to
Mm.
help us wrap our heads around this pretty complex concept. And to do that, it uses these things called magnetic dipoles to kind of represent the bar magnet.
Magnetic dipoles. Not ringing a bell. Could you break that down a bit?
Picture this. The bar magnet, it's actually like a ton of tiny mini magnets, all crammed together pointing the same way. And each of those little guys, that's a magnetic dipole. So the simulation uses a bunch of these dipoles to like create the whole magnetic field of the bar magnet.
Ah, okay, I see. So it's not just some random field they made up. It's based on a model that tries to actually mimic how a real magnet behaves.
Exactly. And what's super cool is the website encourages you to go even deeper. If you've got the right software, you can actually check out the code behind the simulation itself. It's
Mhm.
all open source, so it's totally transparent. Anyone can learn from it, even change it.
That's a side of open educational resources I hadn't really thought about. It's not just about giving you information, it's about letting you see how they put it together, even contribute to it if you're into that kind of thing.
Totally. It can really empower people to like dive deep into the subject, maybe even get involved in developing these
Mm.
resources. And that's just one simulation, mind you. They have this whole list, other resources covering all sorts of physics stuff.
I was just looking at that list. It's pretty amazing. They have everything from rockets to like how the Earth interacts with the bar magnet.
And if you check out their popular tag section, you'll see stuff like quantum physics, superposition. There's a hint, even more complex stuff to explore using these simulations.
It's wild to think all this is out there, free for anyone who wants to learn. It really opens up a world of possibilities for how we think about education. But before we go there, let's focus back on this bar magnet simulation. What really jumps out at you? What's particularly insightful or useful about it?
One of the things I find most valuable is it's got to be how it helps you really get this concept of a magnetic field.
Hmm.
It's one thing to read about it in a textbook, all those words, but to actually see it like in action, that's a whole other level.
Totally. And the fact that you can move the compass around, watch how that needle reacts to the field, those invisible forces. It makes it so much more real, not just some abstract idea. And speaking of making things real, this website, it doesn't hide how it works either, right?
Right. It's open source, so if you're techie, you can dive into the code, see how they built it. That kind of transparency, it's pretty rare, especially for educational stuff.
Now, I gotta ask, what's the big deal about seeing the code for a simulation like this?
Well, it means you're not just using it blindly, like a black box.
Yeah.
You can actually understand, okay, what are the principles behind this? What's the math doing?
So it's almost like you're learning about programming too, not just magnetism, like how these simulations are actually created.
Exactly. It could even inspire some folks to go into computer science or physics, who knows?
Yeah.
And even if you're not a coding whiz, just knowing you could look under the hood, it gives you a sense of trust, like, okay, this isn't just smoke and mirrors.
Makes sense. It's like knowing there's a recipe for a dish, even if you don't cook. Just knowing it exists makes it less mysterious, more approachable.
Perfect analogy.
Mm.
And that brings up another big thing about open resources, accessibility. It doesn't matter who you are, where you're from, if you can afford fancy textbooks. This stuff's available to everyone.
Such an important point. It really levels the playing field, right? Everyone gets a shot at high-quality learning. I'm thinking about, students in rural areas, developing countries, places where a well-equipped science lab might just not be an option.
Exactly. For those students, this could be huge, a chance to engage with science in a way that just wouldn't have been possible before. And even for students who do have labs, these simulations can still add something extra to the experience.
How so? What do they bring to the table that a real-world lab might not?
Well, in a real lab, you're limited, right, by the equipment, safety rules, sometimes just by mass. But in a simulation, you can tweak things so precisely, control the variables, run the same experiment 100 times, change one tiny thing each time, see what happens.
Like having a virtual lab right at your fingertips. No limits, no mess. And because it's virtual, you can mess up too without blowing anything up. That's got to be freeing for some learners, especially those who are afraid to experiment.
Totally. It's a safe space to explore, to test things out, to make mistakes. That's how we learn.
And that freedom to just try things, that's at the heart of science, isn't it? That's how discoveries happen. But it's not just about the freedom, it's also how these simulations teach. They use visuals, and that's so powerful for understanding, especially complex stuff.
Our brains are wired for visuals. It's way easier to grasp something when you can see it. Instead of just words on a page about magnetic fields, you actually see the lines, how they change.
I find myself getting way more absorbed in these simulations compared to textbooks. It's almost like a game, but you're learning at the same time, which reminds me, we were talking about gamification earlier, and this website has that too, right?
Oh yeah, the hide the magnet thing, that's a perfect example. It's a game, it's a challenge, but it's also making you think about the concepts in a different way.
It taps into that natural curiosity we all have, the drive to figure things out. And when you're engaged like that, having fun, the learning just sticks better, doesn't it?
For sure. Gamification could be super effective for motivating learners, helping them develop critical thinking skills. But gotta be careful, use it right.
Right. It's not about turning every lesson into a video game. It's about finding those spots where interactivity, engagement, that's what really boosts the learning.
Couldn't have said it better myself.
Yeah.
And simulations like this one, they're perfect for that.
So much potential for the future of education. It's exciting to think about. But let's bring it back down to earth for a sec. Focus on what's actually available right now. You were browsing the list of other simulations. What caught your eye? So what other simulations on that list really stood out to you?
I gotta say, that Doppler effect sound wave one really caught my eye. It's one of those concepts it's kind of tough to wrap your head around just from reading.
Oh, yeah, totally. You can read about the sound waves compressing and stretching as the source moves, but to actually see it visually, I bet that makes it click so much better.
It really does. And it makes you realize these simulations, they're not just for physics students, right? Anyone who's ever wondered about how the world works, there's something here for them.
Yeah. You're so right. I was drawn to that rocket simulation. I mean, space exploration, it just grabs you, doesn't it? That sense of wonder. And to be able to play around with different rocket designs, launch it virtually, that's just cool.
It really shows you the power of learning by doing. Instead of just sitting there taking in information, you're actively involved, messing around, seeing what happens.
And that's where these open educational resources really come into their own, don't they? They give anyone the tools to be a scientist, an explorer, even a bit of a tinkerer.
That's what I find so inspiring about it all. It's like knowledge for everyone, not just for those who can afford fancy labs or universities. It's out there, free for the taking.
It really is like a whole new world opening up, a world of learning and discovery. Who knows, maybe someone playing with these simulations today will be the next big scientific breakthrough.
Wouldn't that be something? These resources could be sparking a passion for science in people who might never have considered it before. That's got to be a good thing, right?
Absolutely. It all circles back to that core human thing. Curiosity, that drive to figure out how things work, to explore what we don't know, to push the limits.
And these simulations, they give you a way to do that safely, in a fun way. You
Mhm.
can experiment, make mistakes, learn from them, without worrying about real-world consequences.
It's like we're giving everyone a key to unlock the secrets of the universe. And who knows what amazing things we'll find along the way, right?
It's an incredible journey, and I'd say to anyone listening, jump in. Check out that website we were talking about. Try some of these simulations. See where your curiosity takes you. You might be surprised what you discover.
That's a perfect note to wrap up our deep dive into magnetism and open educational resources. It's been a fascinating look at what's out there, what's possible, and I hope everyone listening is feeling inspired to keep learning, keep exploring.
Me too. There's a whole universe of incredible things waiting to be discovered. And with resources like these, the journey of discovery is open to everyone.
Well said. Thanks for joining us on this deep dive.